Welcome, this is Joshua Benoist with Autodesk Product Support. So here we are on video 5 where we're talking about beveled and conical and mitered takeoffs and how they look different between 2008 and the newer versions. Uh, they have contours. So let's look at a problem description. Here's a quick problem description. Pause the video if you need to, and let's move on. So let's pick up where we left off. And what did I mean by that? What did I mean by the teeth of the takeoff fitting? I have a copy of the SMACNA duct construction standards, and we'll forward to the area where it talks about some of these teeth and stuff. So here's the page where it actually shows a little bit about each of these different connection types. So just a rectangular straight off takeoff, it has these flaps that bend outwards, or these clench locks, what they call them, and these tabs fold outwards, and they still need a little, your sheet metal needs a little extra diameter, or in this case rectangular, on the outside to accommodate these tabs as they bend upwards. And so even though they probably can get this rectangular side to be equal to the height of the branch, this tab, I've heard that they can take them straight in rather than bending them upwards, but they don't prefer to do that very often. And so usually about an inch or two on either side in height, so your rectangular main has to be an inch or two taller than your branch in height. So here's a beveled takeoff, and it's really the same way, a rectangular beveled takeoff. The conical ones, here SMACNA talks about how diameter 1 cannot be less than diameter 2. And actually that's not diameter, this is a dimension. Dimension 1 in height cannot be less than this dimension here. And this right here is really a transition from rectangular to round. So some of these other types, like the conical ones and the bell mouths, they're using these profiles here where it still has to have a little bit of meat on the side to hook in. And you still have, so if this is the beginning of your diameter of your branch, it still flares outwards some and then hooks down and in. And so that's why we need to have our duct main has to be a little bit taller in height than either the diameter or the rectangular shape. Okay, so the bell mouse, you might ask, I've been asked before, well, how much does this bell flare outwards? And according to SMACNA, the equation is this radius here equals A over 5, and A is the diameter of your branch here. So, of course, this is just this radius, but if you add on the radius on the other side, it's really 2 times A over 5 is the amount that your main has to be added on to this A value. You can start to build your formula to figure out how big your main has to be in height in order to accommodate this bell mouth connection. Okay, so when you start to see on a rectangular duct main, you start to see these rectangular profiles, it's really kind of a sign that you're probably doing something wrong. You need to choose a different fitting or make some changes here somehow. Use a different takeoff fitting or something. So now let's start getting into solutions. And the ultimate solution is to make your own fitting using Content Builder that has a different shape and transitions from, so let's say that I want a 12-inch diameter here, but I want a more efficient fitting than this plain takeoff. I want it to flare somehow to be a more efficient fitting. I can't necessarily change the height of my duct main though.